Okay, welcome to in week 7 here, supplement 7A, which is how to calculate the perfect order. So the concept of the perfect order is basically saying that if we want to measure the performance of logistics, that we should think about certain errors that are typical, and we can measure those, count them, and the percentage of orders that can get through the system without any of those errors, that come through correctly without any errors, are the perfect orders. Important to understand that means that the implication there is that one order could have multiple errors, but it simply means it doesn't count as a perfect order. So we're not counting the negatives, we're counting the positives. We're counting the perfect orders. So we could have 2 orders with 5 things wrong each, and we're not counting 10 imperfections. We would just be not counting those as perfect orders. Okay, let's do an example so that we're clear on it. So here's some example terms that the book has put in. The error-free provision of a product or service in good condition, delivered on time according to buyer's delivery dates, shipped complete, invoiced correctly, undamaged in transit, and we can find perfect orders as 100% of total orders minus orders with 1 or more defects over the total orders. All right, so it's not too complicated. Just got to make sure we don't double count a fail where we have multiple fails on one order. That's really the whole trick to this, understanding it. So here's an example. Last year, Bartley Company experienced the following results: 5.4 million orders processed, 30,000 orders delivered late, 25,000 orders incomplete, 25,000 orders damaged, 20,000 orders billed incorrectly. So we had 4 different failure modes. We got the data on those. There were 100,000 failures. 30 plus 25 plus 25 plus 20 is 100,000 failures. And the key point that I want to stress here is that those were only spread across 90,000 orders. All right, so we have 90,000 failures from a point of view of the rest of these 5.4 million orders were perfect orders. Okay, so the percentage of perfect orders here would be the 5.4 million minus the 90,000, not the 100. The 90,000 orders that were affected, which would, of course, give us the balance of perfect orders divided by total orders, 98.3%. Here's a question for you to work out. Okay, so get out your calculator. So last year, the Perfection Logistics Company delivered 3.1 million packages and damaged 45,000 deliveries, sent 28,000 deliveries to the wrong address, and was late 30,000 times. Assuming 10,000 of these late packages also had the wrong address, but no other orders had more than one failure, Perfection's percent perfect order is, and how do we find that? Well, we would take let's take the 45,000 and the 28,000 and the 30 and the 10, add those up. Let's get out the calculators. 45 plus 28 plus 30, boom, 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 48 plus 25 plus 30, okay, is 103,000 103,000 mistakes, but we've said 10,000 of those were redundant. So 10,000 of the late packages also had the wrong address. So we have to take 10,000 out of this. They've double counted, right? Minus 10 is 93,000 orders. So there were actually 93,000 orders affected is what I was hoping that you would get out of this question when you're thinking about it. So we could simply then take the 3,100,000 divided by, minus the 93,000 gives us 3,007,000 divided by the 3.1 million is 97% perfect orders. Okay, so do the calculation on that. follow through it. Here's a little quick write-up so you can walk through it at whatever speed you want. All right. But this is basically what we just said. Make sure you remove the orders that were double failures once. Only count them once, so don't double count them. Back out that 10,000 where it would have been double counted, and you'll come up to the right ratio to get your 97% there. Right, 30.1 million minus the 93,000 divided by the 3.1 million. Okay, that's it's pretty much that simple. That is our session on perfect orders.